sessions. And now as we gather for the final leg of our journey, let's dive into the closing session. Ms. Mary talked about Ayushman Bharat, where we explore the potential today's session, we explore the potential challenges of advanced AI and ML models and their interpretability within the world's largest health insurance scheme called Ayushman Bharat. Please join me in welcoming on stage Mr. Suresh Sindhi, appointed Actuary, Life Reinsurance Business GIC Re India, who would be chairing the session. May we have a round of applause, please? He is a fellow and serving council member of Institute of Actuaries of India and the fellow member of Institute of Actuaries of UK with more than 2 decades of experience in actuarial, in stat evaluation of liabilities, product development, pricing, etc. May we have a round of applause again, please? I would also like to invite Mr. Satya Mudigonda, Senior Tech Actuarial Consultant and Adjunct Professor and Coordinator, Center of Excellence for Actuarial Data Science, Sri Satya Sai Institute of Higher Learning as the guest speaker for this session. May we have a round of applause. With 33 years of experience in actuarial and tech domains in the US and India, he is a prolific researcher with a diverse skill set to have managed numerous multi-million-dollar international assignments for major insurance companies across the globe.
Good evening, everyone. So, as we all know that India is currently, a hub for AI, and everybody has been talking about AI. So, government is also not behind as far as adoption of this new technology is concerned. Government has taken a lot of initiatives on AI front. We must have heard Digital India and so on. And now you can see a lot of applications are available. You can just download those government applications and you can see a lot of things on NPS and other kind of stuff. Now the biggest challenge for us is, the health of a common man. As we know that India is thriving economy. We are, I think, one of the fastest growing economies in the world. But at the same time, government is little bit worried about health of a common citizen of our country. Now these are the challenges, because if our citizens are not healthy, then it would be difficult for us to grow fast, and obviously it will have economic and other implications. So how do we address this problem? So health is a basic stuff, right? If you are healthy, then you can contribute to our economy and to your own well-beings. You must be surprised to hear that because of this healthcare and medical cost, year on year, we have seen that more than 5 to 6 crores people, they are just pushing, below the poverty line. That's very, very sad affair. So what government has decided that we should be coming up with some kind of scheme, and I remember the initiatives, the discussion started long time back in the government offices, in the corridor of the decision makers. And year 2018, they introduced a flagship scheme called Ayushman Bharat. Now, I just don't want to go into details of this scheme, but this scheme is basically for those poor and vulnerables, marginalized people. And the main purpose of this scheme was to ensure that everyone should have a sound health. They should really be, living their life happily. Now, to be very specific, Ayushman Bharat is a scheme which is actually covering potentially 12 crore families, approximately 54 crore people. It's basically for poor people, vulnerable people. It's very simple scheme. It's a 5 lakh is the fixed sum insured. I don't want to call sum insured, it's a benefit. 5 lakhs is a fixed benefit. And obviously, this is a cashless scheme. I think last presentation someone was raising some question about portability. Someone was raising question about pre-existing conditions. So all those challenges are there if you just talk about any other private insurance company's plan, health insurance plan. Here, as far as portability is concerned, this scheme is portable. Pre-existing diseases are covered from day one. It's a cashless scheme. So what else you want? So government has done so much, and now obviously people should be aware. I think earlier presentation someone was telling that awareness, because of lack of awareness, people are not able to take advantage of the scheme. The interesting part is about that scheme is actually you don't have to go and enroll. There's an app, and you have to just enter, I think, your Aadhaar number and some other details. Then automatically that app is telling whether you are eligible for this scheme or not. That's it. As per the 2011 survey, caste survey, something like that. Based on some criteria, disability, based on the criteria, occupational criteria and other criteria. So this is all about flagship product, the Ayushman Bharat. Now coming back to advanced AI. So there are two challenges, as far as Ayushman Bharat is concerned. Now the first challenge is pricing. So just before that, I just want to give you a perspective that this scheme is financed by the government, both central government and the state government, either through insurance model or through assurance model. Okay, so when we talk about insurance model, that means obviously there is a kind of a bid or the RFP, and they invite tenders from insurance companies, and insurance companies, they just, quote the premium. So based on the lowest one and other criteria, they decide. Now the biggest challenge is, how does the insurance company decide what should be the premium, right? Because that's the basic thing, right? So can we explore, can we try some different way of arriving at the risk premium? We know the actual methods. Those who are in non-life, they know that they have been doing. But can we just think beyond that? So these are the AI and ML techniques which can be used to arrive at the risk premium. This is part one. So we are going to see that. We are going to hear from our eminent speaker how to derive the risk premium using AI technique. Apart from premium, another biggest challenge is fraud. As you know that many times because of this fraud, a common person suffers, because if there are fraudulent claims, then obviously someone has to bear the cost of that through higher premiums or something like that. So the fraud detection is very important. So in our coming presentation, he will throw light on how to detect the frauds, what are the techniques available through AI and ML kind of techniques. So maybe I would like to request our eminent speaker to share his views and thoughts about both pricing as well as fraud detection through AI and ML.
Thank you. Thank you, Suresh. Greetings to all. Am I audible? So this is our title, but like whatever Suresh gave, a very good background of what we intend to cover today. So we'll keep moving. The next slide. Slide changes with them. So I'll have Dr. Rohan Yashraj Gupta in between, because he did PhD in this area. So he will add wherever it's appropriate. So today's agenda is on why it is important for us. So from the point of view of implementing AI and ML with respect to any of the actuarial models, for now we are taking pricing and fraud detection here. But there are three main challenges which come in our way when we are trying to do this. One is data imbalance, then we have model selection, then we have interpretability. So this is not in sequence, but like we'll address the second one first and then first and third later. Then case study for us is Ayushman Bharat, because that is the most appropriate one to take because it has huge amount of data, world's largest. So that way it helps us to really get to calculate most of the things in the advanced way. Then we also look at actually what is the future of AML in actuarial function. So though we are addressing pricing and fraud detection, that is only the sample part of it. It's a proof of concept. A lot more can be done with this. Going forward, so 35% of global companies, they are actually using AI. So they are not insurance, but they are worldwide, 35% are using directly. Then 42% are exploring AI adoption, and 50% of them, actually in 2023, they are committed to do that. Insurance is slow to adopt, actually. Now only it is really picking up. So when we look at that, like 2.74 billion in 2021, it is going to go up 45.754. That's about, you can see, 15 times by 2031. So more than half of the insurance companies, they are using ML-driven predictive modeling for underwriting, because that's the first step actually they are in, but not more into pricing and other aspects of it. Then most respondents, 75%, believe AI and ML can provide companies competitive advantage. So one is competitive advantage, the other one is actually if they don't adapt, in the long run, they may not exist in the business. So the softer way we say actually competitive advantage, the actually hard way is actually many companies may lose their clientele or business. Then North America, it is in dominant position because they are the pioneers in this area, adopting this particular thing. So moving forward, so if you see data science, it actually follows the actuarial control cycle way. Problem, specifying the problem, developing the solution, and monitoring the results. So here also if you see defining business problem, then we have actually data pre-processing, then model selection. Then interpretability is the place where actually you are monitoring the results. First you are interpreting, then you are actually based on that you are making appropriate adjustments for the purpose. So keeping this in mind, we'll move forward. So these are the three main things we thought actually we'll address today, because these are across all the problems we deal with in the with the data when we are trying to implement AML. So data imbalance, we use various tools and techniques. So for this challenge of data imbalance, we use ADASIN, SMOT, MWMOT, generative AI models. So I'll show you how we use it in our purpose, in our case. Then model selection, you have lot of things, actually XGBoost, random forest. Those who are hands-on, they appreciate actually most of these things, they use that as part of their pricing and other related functions in actuarial side. Then interpretability, this is something new, many are not using, but this is the crux of everything, because most of the low-end activity actuaries need not do. Means what I mean is they can get in, but most of the time needs to go in the interpretability of it, because machines are able to produce a lot of results. So the real crux is sitting in the interpretability. So we applied that in pricing, risk modeling, and fraud detection. So there are two things we looked at actually, SHAP and PFI. So we'll get into that as we move forward. Now, when we look at data imbalance, skewed nature of data set, that is actually is causing the main issue. If we train our model with the skewed data, you'll get the skewed results. So high accuracy also could be deceptive. What it means is, if we have, like, for example, this actually we are going to apply in the fraud detection. 2% of the cases are fraud, 98% are not fraud. So if you take 100 claims, and then you say actually, you run your model, just even if you don't run your model, if you say actually all are not fraud, then you are 98% accurate. it means actually it is deceptive, because when you run all the cases, it will give 98% accurate. So only 2 cases are fraud. So when you have imbalanced data, the accuracy is deceptive. So we need to really get into the actual data features and then build either oversampling or undersampling. So oversampling is one technique where actually you create artificial data with the features of the original one, so that actually both the data set, the fraud and non-fraud, are of equal level. Only then you can apply any of the additional things from coming up from the models. Otherwise, actually it will automatically give a skewed outcome, so which is actually not our intention. Other one is, we can actually move on, like the other one is with the undersampling, where actually you bring down the higher one, so that actually you are balanced. So only in those scenarios, you will be able to get the final output. Now, when you look at section actually machine learning part, challenge 2, we have this entire thing, actually some more are getting added on a continuous basis. So primarily you have supervised learning, unsupervised learning. Under supervised learning, we have classification and regression. Then under the other unsupervised learning, you have clustering. So these are the 3 main things actually which we use in our actuarial work. As technology is actually progressing, we actually more and more newer things are coming. But for our purpose, actually, we can take these 3, classification, regression, and clustering, as main models which we are going to use for our purpose. Now, when it comes to interpretability, so first we are trying to address, these are the 3 challenges, then we apply to our cases. So here, interpretability comes because one is global interpretation, the other one is local interpretation, then model-specific interpretation, then model agnostic. So if you see on the right side, so global, local, model specific, and so here which quadrant it is falling, based on that, you will get a clarity on how to interpret, because models are there, data is there are many automated ways of doing things, like the robotic modeling. It actually, you pump the data, 150 models it runs. So really no need for a person to really sit and do it. But at the end of it, when it throws out the results, which one to take, how to interpret, that matters. So that is the real crux of the entire problem. So this is a challenge 3 we are looking at. Now, Ayushman Bharat, everyone already, the previous session was on that, and Suresh also mentioned that. So 52 crore plus, it may be 54 now. So 3.54 crore plus claims are paid till date. 50% of the contribution to insurance penetration. So what A.K. Singh mentioned, it's a huge percentage. Suddenly with the Ayushman Bharat, it jumped up penetration level. So only thing is, there are other issues, like how Suresh mentioned, pricing and fraud detection. These 2 we can't solve with normal traditional methods of pricing and fraud detection, because data is huge and you need techniques to handle that. So hospitals empanel 28,000 packages covered. So these are all like a massive scheme. So that's why we are proud of having this scheme. It's not like, so we are working on fraud detection to improve the performance of it, but it doesn't mean actually this scheme is not performing. It's one of the best schemes in the world. So here, when it comes to actuarial side, we look at how to improve it further. So, so case study, we are looking at the pricing one. Here, how we select a model. Now, when you look at this, it's a simple way, right? Frequency, severity, multiplied. You get the base, this premium. Then you make various other considerations to that. Then you will arrive. And when you look at actually how we do from the point of view of machine learning models, you look at actually break that into sub-models, like adjust for the IBNR. That is a sub-model which works within the pricing model. Then you have claim seasonality, that's another sub-model. Adjust for impact of hospital empanelment. If you have more hospitals empanel, you'll have more claims coming in. Same way severity side. So if you look at on the right side, we kept tools and techniques that we use. You have burning cost approach, GLM, which are, you all know about that, because as part of the actuarial world, we know all the things which are mentioned, time series, credibility theory, scenario testing, ruin theory. But there are data science techniques which are sitting below. those are the ones which we need to integrate with our work. That's where actually you see the next generation is looking forward. Because we can't solve without adopting, without having the tools. So boosting, GAM, neural networks, support vector, SVM, classification, CART, okay, clustering. So these are all the methods which actually tools and techniques which come in your way to make it happen. So now these are all the things one by one. If you see, actuarial side, you know, chain ladder, you have Cape Cod, Bonhoeffer, Ferguson. Whereas data science side are packages for that, neural networks, distribution. So this is, I'm talking about the adjusted member count for exposure period and IBNR. So very specific to that submodel, these are the tools and techniques we use, both actuarial as well as data science. When we combine, then only we will actually be able to see the results. So that's where actually we explore that and we see greater results there. So similarly, just for claim seasonality, we have different set of things which are coming up there. So every submodel really has a different set of data science as well as the actuarial statistical things. So when we implemented this way, we found that each one of the submodels are fine-tuned in a nicer way so that you will be able to adjust that in a very effective way. And then if anything changes in future, like in this case, adjust for change in packages, it's a major change in Ayushman. 2018 they started. Again, after 2 years, they changed the packages. So there is a way to handle such a situation. So now, at the end of it, all those things, they lead to output of risk premium, which is, you cannot say pinpoint, this is the premium. It's going to be a lower end and upper end. So that is how actually we arrive at a base risk premium. Then we get adjusted claim seasonality, adjustment for hospital empanelment, like that. Various adjustments will come and it will arrive at the final premium. So this way, if you are doing pricing, you will get very closer to the real experience. Any other way, like the economic way of doing things, it's possible. You can, when you start a scheme, you will do it in simpler way, approximately. But after having experience from 2018 to 2023, really you can do. So here, what are the benefits of using ML in pricing? So these are the informed decisions you can take. You avoid overpricing or underpricing. Then you can be in business. That actually helps because you need to go with the technology aligned with that. Then it also helps actually to make adjustments and a better product design, because pricing correctly also helps us actually design a product in an innovative way for the future. So if you go forward, so that was actually related to regression type of thing, addressing the selection of the model. But when you look at other two, the data imbalance and the interpretability, so if we take an example, fraud, 46,400 claims out of 3,82,000 as an example, as a like fraudulent cases, then we look at actually we train 75-25%. Then you can actually look at how we get it to this is an imbalance situation for us. 88%. So whatever you do, 88% accuracy you get, which is actually deceiving. So for our purpose, to get to apply our models, we have to do undersampling or oversampling. When we tried both the things, oversampling is the best one to actually get it. Now when we move forward, like SMOT is the one where actually we use this particular thing, and then we looked at actually how it helps us. So we could create a synthetic data, because in SMOT you have a target thing. So in between the neighborhood, we actually create. So let's say simple example is average of it is a one way of doing things. But if you take the entire space and then try to average it, then you need actually a model, like you have a tool and technique. SMOT is one of them to use. Similarly, you have, when it comes to interpretability, you have SHARP and then PFI. SHARP is sharply additive explanations. Then you have permutation feature importance. Both are two different ways of interpreting the output, but they may give slightly different thing. So with what is the purpose of the model, that will help you to identify which one to use. So using that, you can actually see the important feature importance. Each one of these, actually whatever we mentioned there, is a feature. Gender, primary, procedure, claim amount, flag, birth date. These are all the features which are actually going to help us to identify the fraud. So when you look at how we are actually getting to the end of fraud detection, we are actually doing the imbalance of data to a proper level, applying various models, the way we did actually for the pricing. So here is a classification models which we use. Okay, then we interpret it using one of the appropriate methods like SHAP, or we also have Lime and other things. So whatever is the most appropriate thing that we use. So going forward, if you see how to really apply these things to Ayushman Bharat, so that's the case study we did, and we found the way of doing ML in such schemes actually provides greater appropriate results for us in our business. So if you see, the benefit of it is you cannot identify, you say this is the fraud, there is no target element for the fraud because it keeps changing. If you know 15% fraud is there, that means actually you have identified 15%. Fraud could be, in reality, maybe much more than that. So as we progress these particular things, fraud, the different types of fraud also goes up. So you need a model which is actually learning on the fly. So that is where human, like our traditional way of doing things, it doesn't work. So we see these are the 4 different benefits which actually we can gain by doing. The most important thing is cost-effective part of it, because when we contain the fraud, we actually build the trust and then also reduce the premium for the future. So with this as a background, where we are leading, if you see that, so whatever we have done is only the 2 functions of actuarial area. One is pricing, the other one is fraud detection. But it can be applied to multiple other things, where like reserving, valuation. So the scope is enormous, unlimited. With the data that we have in each of the insurance companies, the adaptability of AML is actually huge, which will help us to serve better. Not only that, actually we can price or detect the fraud in a most effective way. So any questions from your end? Yep.
So thank you, Sai. It was slightly technical, so मुझे बहुत ज़्यादा समझ में नहीं आया, but थोड़ा आया है ऐसे. So my question is more from application point of view. I think on day-to-day basis, I think we discuss a lot about this machine learning, building AIs into fraud detection, underwriting, profiling of employees, profiling of distributors. So many problems. I think whatever come, I think we try to solve it through AIs and all these models. And like you mentioned, it's going to give lot of power and strength for actuaries to do things in a different way and more accurate manner, right? From disruptions point of view, I think what I can think of, like many of us do say reserving and pricing and lot of data processing, right? So like a team, say valuation team, what does? Someone is doing experience studies, someone is setting assumptions, someone is validating data, someone is running models, someone is extracting output, interpreting it, and all these things. And if this AI and ML is going to be so powerful, right, you can code everything, isn't it? Automatically, it will pick up data from your policy admin system, it will do analysis, correct, it will show assumptions and all these things,
yes,
right? And you feel that the actuary's role is going to be different now, like whatever we have been doing, we are doing all these activities, more going to be doing by AI and ML, and actuaries have to find out some other role into that process.
Actually, yes. Very interesting question. Like few years back, actually, there was what we can outsource. You know, that was actually coming up from the actuarial function. So are we doing as actuaries the quality of the work that we are actually supposed to do? Because if we are getting involved in data cleaning, data collection, then data analysis, representing it in graph, these activities can be done by a statistician very effectively. For this job that is actually can be done by a different skill set person, for which actually the amount of money that needs to be paid per hour is very low, a very high-end actuary getting involved is very expensive. Actually, even without AI, certain activities which are currently being done by actuaries, they don't belong to them. Why they get in? They say, actually, we don't have trust. I have to see the data, then only I'll trust it. That's a different aspect of it, but those days are slowly moving out. So we need to look at actually the qualitative aspect of actuaries' work is not going to go out, because interpretability is the one which actually, if actuaries fine-tune their skill set to adopt to that, because there is no way, because we moved from calculator to Excel to this one, R, Python, then Power, then we get into the next one. So the tools are becoming powerful, data is becoming huge, so there is no way, traditional way of doing is going to keep us alive in the business market. So for us to, because that's where actually the first slide, 35% adopted, 50%, reality, it is not like imagination now. So if insurance is not adopting that, those who are not adopting, they may go out of business, as simple as that. Initially they'll go into less profit. Same way, actuaries, if they are not adopting into the next level of things, because we are not saying that it's a different skill set. It is actually the input for you is coming from AML model, but you are making a decision the way you are making a decision with additional skill set. So that is where actually I see actuaries' role is going to become more and more powerful. They will be doing more qualitative work, because the power robot, actually I want him to just add, those things actually, if we feed the data, it will do data imbalance, data cleaning, complete set of all the things what I showed in the data flow, science flow. Everything it does in 4-5 hours, 150 models it will give you output. Then what do we do? Now we have to actually look at which one is relevant, because some of the things may not actually make sense. Machine may not know. So that is where actually we are getting actuaries qualitative work, because the AML ideally should improve the quality of actuarial work than actually bringing it down. So I see more actuaries getting involved, not only in insurance, actually anywhere risk is there. That's how actually I'm seeing. Okay? Thank you. I just want Rohan to add one.
Yeah, you pointed out a very appropriate question, right? Like, will it disrupt the actuarial profession? So at this point, I'd just like to draw parallels with what data science guys are doing right now and what actuarial guys are doing right now, right? So if you look at actuaries working in the field of data science, as an outsider, you would find that both of them are doing the same thing, right? But where is it that actuaries actually are making difference is the third challenge, which was being stressed upon a lot, which is the aspect of interpretability, right? And sir also mentioned about the data robot. So in my previous organization, right, there is this model called data robot, and I was amazed to see that you just feed in the data, the model will churn out 150 plus models in no time. All of the models like data, the random forest, SVMs, all of fancy stuff that we hear, right? It just churns out. But what it cannot give is the interpretation. So yeah, as we go ahead, the actuarial career, we need to adopt the data science skills, and we just need to make our skills more niche so that we are able to interpret, because tomorrow everything is going to be AI and ML, right? So we should have skill sets enough to be able to interpret what the models are doing. I guess that's the key takeaway. Yeah.
Thank you, Rohan. Rohan is PhD in actuarial data science, one of the first to complete in the country. That's where actually the more reliability comes from his side. Okay. Thank you.
Thank you so much. Wonderful presentation, quite informative, and obviously we actuaries have to be agile, and I think we are adopting these different new techniques. I can say that at the end of the day, whether we use actual technique or techniques, data science, AI kind of different techniques, end of the day, it's very important that we should understand and interpret the results, and we should be able to convince those results to our stakeholders. Because already, many stakeholders, they said, you guys are super brilliant, you do a lot of wonders, as far as numbers are concerned, we respect you, but many times we don't understand, how those results have come. And unfortunately, many times we are not able to, give them, or we are not able to communicate the way in which, the non-actual audience is expecting from us. So we should be focusing more on that. Models are great, complexities, could be there, but I remember in the early morning plenary session, our eminent speaker, he said, we should keep the things simple. And simple is not very simple in our life. Unfortunately, we make our lives very, very complex. But we have to just bear this thing in mind that these models are not for us. These are for the end users. And we should be able to explain that to them. So thank you, both of you. Very, interesting and informative session. Thank you so much.
Thank you to our speakers for the amazing session. May I please request Mr. Kartike Kandoi to present the memento to the chair and speaker, and also to the co-author Dr. Rohan Yashraj Gupta for the memento. You can please come on stage. May we have a big round of applause.